Connected Consumer.
Hello, connected consumers. This is Chris White.
And I'm Rosey Sera, and we are the hosts of Parks Associates podcast, The Connected Consumer.
This is a podcast where we bring our primary research data driven insights to a conversation with industry experts from all the different verticals that we cover at Parks Associates and also some of our own colleagues in here to have conversations.
Yes. In today's episode, we're joined by Sayeed Ahmed, director at Infineon Technologies. Welcome, Sayeed. Thank you for joining us today.
Hey, thanks to both of you.
Thank you. So please tell us a little bit more about Infineon and your role there.
Yeah, Infineon is a technology company. We are number one in semiconductor in the automotive area, and also we supply semiconductor to all the other industries, windmill and solar, and server and all the other areas. I am focused on the automotive side, and we have different application segment. I take care of the electrification segment as well as the powertrain in the combustion engine. But right now, as you know, the electrification is a hot spot now, and we are really have a lot of exciting things to offer.
Amazing. I'm excited to learn more about it. So, Parks Associates' latest research shows that more than a third of households are likely to purchase a vehicle in the next year. More than half of those intended buyers have started shopping for electric vehicles. So, I want to talk more about EV adoption. So, could you tell
Mhm.
us more about the benefits of electric vehicles when it comes to not only the environment, but consumers and the market overall?
Yeah, I think that electric vehicle. If you think about what's going on right now, is the in terms of the environment, we know that this warm weather is going across the world right now, and EV is definitely uh, one of the most effective way to reduce these greenhouse emissions. So I think there is a benefit for it's for the environment definitely, as well as it helps the consumer and companies to take an active role to mitigate this climate change. That's number one. Number two, EVs also are actually is very in terms of lower operating and maintenance cost. I think this is a significant benefit that and because it's very few moving parts, and as well as anybody who drove a electric car, that this is fun to drive. I mean, if you look at the 0 to 60 or the acceleration wise, and it's really fun to drive, and because it's electric and you have a lot of electric power, you can have a lot of gadgets there that you cannot have in the standard car.
Yeah, absolutely. I think those are great benefits for not only the environment because I feel like, recent generations or even older generations, they're way more environment conscious and they want to participate in the positive impact that, these vehicles play when it comes to the environment. And of course, they're so fun to drive. I was a passenger in a Tesla not too long ago, and they go so fast. They also have really fun features with like the screen, and you have games and stuff. So I completely agree with you on that. Chris, any thoughts?
Yeah, I mean, so we study connected devices, and there is this conversation that's happening now about what is the fourth screen, what is the fifth screen, and the all of these electric vehicles, because there is so much already electricity, electrical resources on board, all have these telematics. Also, because of the nature of charging, um, and the nature of some of the other functionalities of how these vehicles work, they're naturally designed to be connected to um, internet and use more features. There's all sorts of developments in terms of integration with smart home devices that connect the cars themselves to the devices that we already have in our home. There's voice can there's voice control features that some of the companies are incorporating, including like Rivian has Alexa, for example, incorporated
Mhm.
into their
Yeah.
all of their telematics. And there's really no the sky is the limit in terms of kind of devices we can put in there. So we're really excited because this is the type of research we do. We have an entire report that I just actually published about electric vehicles and the growth there. So we're excited to have a subject matter expert on the pod to kind of talk about that. Such a hot topic right now.
Right, because you touch on a very important point. If you look at the the vehicle to interface to home to vehicle to our rest of our life, it's getting a lot more integrated, right? I think that's what you mentioned, that the Alexa integration,
Right.
and this is a fun time definitely to see all these technologies coming together in a vehicle, but also it's getting very much integrated to our home life, right? So that's very exciting.
Yeah, totally. So now that we've covered some of the benefits, I'm interested to know what the challenges are. So the microchip shortage has played a role in the lack of supply for EV manufacturers, which could
Mhm.
lead and probably have led to pent up consumer demand. So tell us a little bit of, what other challenges are EV makers facing while trying to drive consumer
Mhm.
adoption these days.
Yeah, absolutely. I think the first thing I would say is cost. I would say that, as you know, that the vehicle makers need to make money. And I think the cost, you can look at the two aspects: development cost and production cost, right? These are new technologies, not like we have a mature, internal combustion engine technology you can get in and integrate it. You need to develop a lot of those technologies, and the development it takes pretty big amount of resources, and that's the cost, as well as the production cost wise. We have to right now the production cost needs to go down overall, and when Infineon as a component supplier, we always focus on system cost, because at the end, what is the total vehicle cost, what matters. So that's number one. Number two, I would say the development time. As you know, that there is a race going on right now, and who can get the coolest electric vehicle out on the road. And the development time typically in the internal combustion engine area was 5 years, even with the mature technology. And now, if you look at the Rivians and Teslas, they're trying to reduce a new technology, but the development time is reduced by half, like 2 or 2.5 years. And this development time is a key challenge, and especially lack of expert resources. Some of the areas that electric vehicle expertise is needed actually was not needed during the dot-com area and those the previous revolutions in the overall industry. So there is a lack of resources in this high voltage and overall resources that are needed for this kind of stuff. So that's number two. Number three, I would say, charging infrastructure still is a challenge. I think that some of the manufacturers have built a very good infrastructure, but for most of them, the charging infrastructure is very much needs to be developed. And we know that with this infrastructure bill, that is actually will take care of part of these issues, but it's going to take some time. And I think this charging infrastructure will also influence a lot of the adoption. I think you were mentioning about one third. I think if you want to go to higher adoption rate, charging infrastructure is definitely one of the element to focus.
Right. And I think some of the some of the issues you discuss are kind of pointing to a another issue that like we've talked about in some of our pre meetings, which is the types of electric vehicles that are coming onto the market. The ones that are on the market today are kind of existing in a niche space, and then the next wave of vehicles that are coming in are a little more diverse, but are still all above the sort of average new purchase price. And so something we had discussed is, because this is a new technology, it's directed at um, sort of early adopters. It's also vehicles that are going to be a little high end, but that does kind of leave out certain members of the customer base, right?
Hmm.
So so with all that, so that is something that we're going to have to kind of watch as we continue to track the data on our side. And when you guys are working with different partners in the future, whose components you're going to sell for, like the Infineon components are currently going into $75,000 cars, but maybe in the future they're going to be going into $25,000 cars. And so our data shows right now that a lot of the EV buyers are looking at luxury or sports cars, and so
Mhm.
that's gonna maybe be okay with the price point in the next
Mhm.
12 months or so, but
Mhm.
there is also a large market in the kind of ICE
Mhm.
vehicle sector for SUVs. Like, we
Yeah.
imagine American vehicles
Mhm.
as being SUVs, so it's gonna be interesting to see how some of these, legacy OEMs that are coming in with their SUVs are gonna do, and then also, like, Rivian coming in with their pickup trucks and, SUVs only. They don't even have a luxury car or sports car to offer. They're kind of facing an uphill battle in terms of creating demand for electric versions of those vehicles, potentially.
Mhm.
So 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 thank you for kind of sharing your input on, how you see the growth of EVs going in general. And, that's great. It's great to have an insider's point of view on that. So we really appreciate that. But we should also, while we have you, ask you more specifically about Infineon's contribution. So talk to us about some of the components that you guys have going into
Yeah.
EVs, and
Yeah.
yeah, and what's coming down the road too.
Yeah. I think that's actually this is one of the most exciting, the time for us because we are a very broad-based supplier. So we have pretty much, a component that goes across the board. So let me be very, very more specific. If you look at the electric vehicle, I would say from the electronics point of view, there are three major components, right? One is this inverter, and this inverter basically drives the motor. It takes the DC electricity from the battery and converts it to the uh, current and converts and controls the current that are needed for the motor, right? So this is kind of the equivalent of an engine. And so inverter is one area that in Infineon pretty much have, I would say, 90% of the bill of material that goes there. So for example, the power device, the driver IC, the sensor and microcontroller, and several other components. So that's one of the key components. And second key component, I would say, for example, a charger, right? There is an onboard charger. Of course, there is a charging station charger. So the onboard charger wise, this is also again, Infineon has a lot of these components, and we have the power device, driver IC, microcontroller, even some of the charger authentication and those kind of technology also we have from our chip card division. And the third major electrical system is the battery management system. As you know, the batteries are kind of the power plants of the car, right? So, and how do you make sure that the charge that we have in the battery that's kind of equivalent to gasoline, right? How do you make sure that you really, you know, optimize the battery? How do you control all those cells, and then how do you make sure that the efficiency that are kind of goes from the battery to inverter is the maximum efficiency. You don't want to waste any energy. We have multiple components that goes also in the battery management system. In addition to, as you know, batteries also is a prone to some thermal runaway and those kind of situations. We also have a lot of sensor and electronic products that are there for battery protection. So these are the three major systems, and we have components pretty much on all those areas. So as I said, almost if you look at this inverter, charger, and BMS, we have 90% of the component that goes there. So that makes us a very efficient player because, as you know, in a design you have to optimize, and sometimes because we have so many components, we can really see, okay, how do we make sure that the overall system wise it performs the best way. And so we have a lot more levers than if you had just one or two components.
Yeah, I mean that makes you guys highly essential across the entire kind of value chain of production there. So that's a good position to be in for you guys for sure in a market that's going to grow like this. So I wanted to kind of touch on one piece that you mentioned in there, um, and that's thermal runaway. So
Mhm.
just in case the audience doesn't know what it is, can you talk about that a little bit? Because I feel like as this kind of market grows and more people start to learn about EVs, there's going to be a lot of sort of misinformation, or
Mhm.
kind of some people sowing some fear, because big change always comes with that type of
Mhm.
thing, and there's also moneyed interests on the other side. So
Right.
we could see
Mhm.
some press about this type of thing, and so I was interested
Yeah.
if you could talk a little bit about your role. So first of all,
Yeah.
like, what is thermal runaway, and then the other thing is, like, what is Infineon doing
Yeah.
just to kind of keep it safe?
Yeah. Okay, now that's a great question. As you know, that sometimes you see in the press that, hey, this electric vehicle is burning and they show the fire, right?
Right.
And a lot of time the source of the fire could be a lot of different things. But as you said, customers sometimes gets misperception that, hey, this is an unsafe car or something like that, right? So a couple of things let me bring to the very foundational. One is that the battery production right now is actually very precise, and they spend a lot of energy to make sure that batteries are very well controlled, right? So each of these cells, actually cell manufacturing is not like what it used to be like 30, 40 years ago, like a battery just put some mixture and put it in. But they actually do a lot of tests in each of these stages so that battery cell itself is very safe, right? But what happens is that sometimes there are several reason there could be some challenges in the battery. One is there is this state of charge. There is a certain range people try to be in there, right? Because of the just so that the chemistry doesn't chemistry kind of is in this controlled area. So what could happen is that sometimes there could be some reaction in a battery that either from impurity or something that was not controlled, and there could be some internal reaction that could be one source that battery gradually becomes overheated, and that there could be something of that nature. The other potential scenario is, as the battery are kind of packed and it's really very well protected. But if you have a collision, or even maybe during the manufacturing, let's say if there is some kind of battery cell damage, is it dented or something like that, right? Then you are kind of compressing the chemicals there, and there could be some reaction. We are not the battery expert, but in terms of those kind of situation, what our role is, how can we make sure that we have the electronics, and especially we have a lot of sensors, and also some of the way how we continuously monitor the cell, and if we see something funny going on, we can sense that and we can report it to the batteries. Right? For example, most of the batteries right now uses these pressure sensors. So whenever they see some pressure, because of this, if there is a build up pressure there, so they can sense it and they can report it. Sometimes they may put, more than one sensor there. So what we are bringing for what we're developing right now, one is what we call this impedance measurement, and this device basically will continuously monitor this battery, some parameters that will indicate if the battery is still healthy or not, right?
Mhm.
And the important part about this technology is we're trying to, we already have test data that showed that we can detect this kind of um, change in the chemistry, battery characteristic, from measuring some electrical parameters that is a precursor to the thermal runaway. Okay, so we can detect those significantly earlier than when the thermal runaway happens. The way we envision, we're working in several OEMs and our customers to see how can we implement that kind of methodology so that drivers get warned ahead of time so that they get some warning message and they kind of not drive the car, they take it to a safe place. So we're making sure it's not like a couple of seconds or minute that before it happens, but it's a hours maybe to make sure that we see some detection and the driver takes it to the garage for checking or get some warning message. In addition, we are also developing some hydrogen sensor because when battery starts to leak, then there is some gas that comes out, and this hydrogen sensor is another area. We also have the pressure sensor that presently are used. What we're looking at, like, how can we, with all these sensors and devices, as well as we have microcontroller that where you can really put some artificial intelligence, taking all those data and kind of making sense out of it. How can we do a much more comprehensive approach so that this kind of battery fire doesn't happen and is detected a lot earlier than when that is likely to happen.
Right. I mean, prevention and monitoring is going to be key in that, to reduce, consumer concerns about that peace of mind. And this is a rare scenario we're talking about anyway, but it's awesome that you guys are developing technologies that are going to be, preventing more of that as people grow. But something that I was thinking too is that another consumer concern is that while we have a bunch of legacy OEMs coming in with their electric vehicles, we have Volkswagen right now, Hyundai and Kia are all have kind of strong EVs in the market, but we also have a whole bunch of new entrants. So Tesla kind of made its way to the point where a lot of people know the name, but people do have
Mhm.
mixed opinions about kind of whether they trust Tesla, right? So
Mhm.
I was curious from your perspective, you guys are trying to sell to everybody. So, what has your experience been like working with kind of two different, very different business types in terms of new entrants that are coming from kind of a tech perspective versus legacy automakers that are kind of converting over from 100 years of
Mhm.
making internal combustion cars?
Yeah, no, this is a very interesting question. Actually, as you know, there's being a number one automotive supplier, we are kind of engaged with a lot of the names that you mentioned: Tesla, Rivians, and Lucid, and as well as the Ford, GM, Volkswagen, and all the traditional players. So I would say it's a very interesting observation that these two sides actually operate quite different. I would say maybe I'll give some examples, and but in terms of the key differences, I would say first is this mindset, right? Um, this is a new technology, and everything is not known. So a lot of time you see that the traditional OEMs, if I look at they have a very methodical approach, right? So they are in general risk averse. Um, but if I look at you know, the new players, I mean, they are kind of very like attitude wise, mindset wise, like, okay, it's what I call it mission impossible mindset, right? Making it, take the impossible target and make it happen. And I think this mindset is very important because that kind of defines how you view how do you develop technology and all those areas. So I think I'll give some examples later on. The second one, I would say, in terms of how do they look at the development, right? If you look at the traditional, they're trying to take some of the development step inside, but it's still they have this, OEM does something, they specify and they give it to tier one, and then tier one goes to tier two. They're breaking that some in some areas, but fundamentally it is still a sequential step by step approach. If I look at the new players, they're much fast and agile, and the reason, most of these new players actually are not utilizing a traditional tier one. They're kind of OEM and tier one. They're also developing their own system, because of this, fast and agile approach that, hey, I'm going to try something. If I fail, let me learn from it and then fix it and get to the next one so that I know how I can develop something fast. So this development approach is quite different. The other major difference I would say is the decision making. I think this is where the traditional OEMs are trying to change, but it's not that easy to change such a big organization that has been living that kind of decision making for a long time. So very much hierarchical and slow. So basically, the engineers a lot of time don't make the decision. Then you have to go through the supervisor to manager to director and vice president. So there is a lot of this hierarchical approach that kind of slows down the decision making process. On the other hand, if I look at the new players, they really empower the front line. Like engineers are empowered to say, hey, I'm going to make this decision. I don't have to go through 20 different reviews to make that decision. So that's why kind of it goes with this fast and agile approach. You cannot be fast and agile if you cannot make decisions. So these are the three major areas. I think we see that it's quite refreshing to see that in automotive development has been very traditional, but guess what? When you bring the new blood, new players, it can change. And this is, I mean, for me, it's very exciting because I have been in this industry for a long time, and I can see that how this 5-year development cycle can be reduced to 2 or 2.5.
Yeah, it's really interesting watching the new entrants kind of adopt some traditional methods after they kind of make mistakes and have missteps, but then also you see some of the legacy people making some, I think, pretty big moves. Like Ford recently came out with that announcement that they're going to sell F-150 Lightnings direct to consumer instead of through
Yeah.
the dealers.
Hmm.
I mean, that completely changes the landscape of how vehicles are sold, and now is moving to kind of more how we see other electronics being sold direct to consumer, where the manufacturer is really in control and there isn't a whole bunch of channel partners. I mean, that really changes the landscape and maybe appeals to a different generation who's used to buying that way, especially in the last couple of years when we've all been ordering everything and having delivered at home. You know what I'm saying? Why not a
Right, right. Yeah.
$75,000 car like
Yeah.
dropped off
Hmm.
at your house, right? So
Yeah.
Tesla's been making it happen.
Yeah.
So everyone else has to kind of meet them also, but then
Yeah.
also bring some of their expertise and leverage their dealer networks and things
Yeah.
like that to kind of get an advantage.
Right.
So in this kind of dynamic climate where we have the legacy automakers bringing their expertise and innovating, but then also the new entrants, there's potential for all sorts of new growth and new technology. So we talked about the things that EVs can do very well today, but there's also all sorts of things that are interesting that are potentially coming down the line. So one we talk about is V2X, right? So like the ability to charge your house, the ability to charge, give electricity back to the grid, the ability to be a demand response component. Another one we have is all sorts of different ways of rolling out the charger network in terms of putting them in commercial like parking lots versus people at home. So um, and then, of course, autonomous vehicles is one we periodically talk about and get excited about. And I'm
Mhm.
personally medium scared about that. So if you think that it's going to be safe and cool, please tell me. Otherwise, but otherwise, like just kind of let me know like what. So maybe Infineon's going to be involved, or maybe they're not. Maybe you're just interested because you're an engineering type guy and you follow this type of technology. But tell us what technology that you see the EV world coming out with in the next couple of years that makes you kind of excited, that you're feeling kind of optimistic for.
Yeah, I think that EV, if you look at, for example, if you look at Rivian, they really redefined in some ways what an SUV and sports kind of brought this sporty feeling about the SUV. But not only that, the way they are marketing this is really interesting, right? In a camping trip, and you can sleep in your car. And I think this. I think there are some of these things, and I was in Europe a couple of weeks ago, and this the VW is coming up with this vehicle that you can really sleep in your car very comfortably, right? And these are we I mean, of course, people can sleep in car now, but it's not that intentional, right? Okay, if you have to, you do. But now they are even designing cars where you may not need a permanent home, right? I think we'll see a lot of exciting technologies that are really kind of is bringing not only the vehicle technology, but how we live our life, right? And how do we connect to the rest of the rest of our rest of our the overall time. Usually vehicle was just used from going from one to point A to point B, but I think that's definitely not happening. I mean, that's happening, but I'm saying that there will be a lot more additional values there. That's I think is coming. But I would say that one of you mentioned this autonomous vehicle, right? Autonomous vehicle, as you know, needs a lot of power, all this lidar and radar that you need to make sure that is the eyes and ears of the car, right? They actually need a huge amount of power. Actually, one of the observation that came early on in the autonomous vehicle, that autonomous vehicle, you cannot use just this 12-volt battery in the internal combustion engine. So all autonomous vehicle by by kind of it needs to be electric vehicle, because in electric vehicle, as I said, it's a power plant. You have so much power is that you can use for all those sensors. So I think this is where I feel that it's like each of these technology are feeding into each other as well, and making it better. And in terms of the safety of the autonomous vehicle, I mean, look at we got used to this blind spot detection. We got used to this now, like a warning sign. Like I right now, I know when I am in the highway, we depend on this automatic cruise control, right? So these are these the change comes gradually, of course. I mean, and I think what I would say is that the autonomous vehicle is not a pipe dream anymore. It's coming. It's reality. But a lot of the feature, even if you look at the Tesla's this autopilot, right? I mean, it's a pretty good feature. And I was in another car, in a GM car with their Super Cruise, and it's great experience. I mean, you just tell to go, it not only just maintains the distance, but it can overtake the next lane vehicle and do it very safely. So I think it will. I think the confidence will grow, and I think someday you will be in a autonomous car, I'm sure, and maybe I'll be with you next to you. Okay.
Yeah. Okay. Great. So I feel like this has been a great podcast for me in terms of relieving my anxiety. Saeed says my EV is not going to blow up from a runaway, and no autonomous vehicle is going to slam into me on the highway while the driver is taking a nap or something like that. So that all
Mhm.
seems great, and I definitely agree. I really like. So you mentioned Rivian in the camping thing. Their idea to put chargers at national parks is really neat in terms of expanding who the audience who's going to kind of a LL Bean uh, type audience coming for them. The other thing is that we're starting to see fleet vehicles come on board. So speaking of Rivian again, but
Mhm.
also a couple of the other uh, big car makers are making electric delivery vans, and
Mhm.
that's something that it was a bit of a trend, I guess, the past couple of years in terms of converting sprinter vans into like campers. So I think once we start seeing a bunch of these new electric delivery vans on the market for a couple of years, people will start to see some conversions. So I'm excited for that. Maybe I want to get a airbrushed like wolf howling at like on a mountain. You know what I'm saying? On the side of my converted van. This is a dream. I just have a lot of dreams, guys.
I love it.
All right.
Yeah.
So Saeed, tell me if I miss anything. If me and Rosie didn't ask you about something that you want to be sure that you mention, and also plug your work. Tell people how they can meet you.
Yeah, I think I would say one of the topic is like how do we go from where we are right now, which is an exciting time, but next 5 years 5, 10 years of growth in EV is a huge growth opportunity, right? And with that opportunity, as a semiconductor company, first of all, we are committed to do our part in the greenhouse gas reduction, and we announced that target publicly. But at the same time, this is an exciting business to be in. And also, I think as I said, you mentioned about this. We have this like premium vehicles right now, mostly. It's gradually, transitioning to the low cost vehicle, and there are people. We are working. I can tell you that we are working with some of the OEMs about these high volume vehicles that you're mentioning.
Great.
It's like what I would like to emphasize that we need to work as partners with the OEMs, with the tier one, to really understand what is the goal and how can we design things that kind of optimizes the cost and performance need. And we have been successful in multiple cases when people opened up the kind of we need to break down some of the walls, because a lot of time people don't want to share information. And I think that's a very important part when there is an industry a revolution going on in the industry. In order to move fast, some of these barriers that are have been in the traditional value chain, I think needs to be broken down, and we are successfully breaking in some cases more difficult. But this is we have multiple cases where we were able to really do a very cost effective solution. I'll give you a story. The One of the North American OEM built a very big SUV, and in that one, they wanted to have a very high acceleration for a short duration of time, and they came up with that feature at a very late time. By the time they already designed a lot of things, they said, "Hey, we need to increase the current 20% for the short duration. Is there a way that you can help us?" I said, "Okay, that's a great, offer, kind of a project for us." So we, instead of just working with the OEM and us, we said, "Okay, let's bring the tier one partner, bring the rest of the value chain, and see what is the critical factor to increase this 20%, and how each of us can contribute to make it happen." I'm very excited to say that within a couple of weeks of discussion, we came up with a plan and we implemented that plan. And I was fortunate to be in that car when they did this acceleration, and it was awesome. So what I wanted to mention is that the collaboration and partnership is very critical in terms of not only to reduce the cost, but also reduce this development time. Because the more we share information, the better we can offer the best solution for our customers.
Yeah, that's a great note. We talk about interoperability on basically every episode of this podcast. So probably our listeners are rolling their eyes or punching their bingo cards to indicate that we actually said it. But just the way that new technology needs to work in a network, be it maybe it's removing walled gardens on charging, maybe it's working with connectivity and standards on telematics, or charging payment models, things like that. Like there's a lot of people that need to come together, put their heads together to make this work. There are a lot of people talking about V to X as something that is going to require a lot of coordination between a lot of different partners. So as this grows, it seems like it's going to benefit everyone to work together in kind of a rising tides lift all ships kind of scenario. So I appreciate having you on here to talk to us about how you're kind of helping add water to that. I got lost in my metaphor. Sorry. You're helping lift ships, right? Infineon's doing good work for the EV world and for those of
Absolutely.
us who are trying to drive non-exploding, extremely fast cars, right?
Mhm.
So that's great. So Saeed, that was good. Sorry we didn't touch on that topic long enough, but I'm glad you shared that story. That's a cool one. Um, so I wanted to kind of thank you for your time, and we're kind of wrapping up here a little bit. Let everyone know that they can find Saeed Ahmed on LinkedIn. And also, Infineon has a great Twitter presence that pushes out a lot of good information. So go ahead and follow them as well,
Mhm.
and then follow me. I try and push out good content
Sure
too.
does.
I
Yes.
try
All
at
right.
CY Insights, and then try and follow also Rosey at Rosey Alpina Sera. Follow at Parks Associates. Follow Parks Associates on LinkedIn. We got all sorts of information that we push out there. All sorts of freebies in terms of research that we put out, that you can get great information. And then also in terms of helping this podcast grow, please rate and review, subscribe, tell your friends, check us out on YouTube if you've mostly been listening to the podcast version, and vice versa. And we thank everyone for listening. We really appreciate your time today.
Thank you, Saeed.
All right. All right. Thanks, Chris and Rosie. I appreciate the time.